Muscular dystrophy is an inherited disorder most commonly found in young males. It is characterized by degeneration of muscles, which progressively causes weakness, inability to walk, limited range of movement, and poor blood flow. Many cases of muscular dystrophy result in patients in motorized wheelchairs. Despite such a useful technology, patients have a difficult time using the toggle to move the chair due to a lack of oxygenation in the muscles from poor circulation. Heating the hand allows for better blood flow and increased ability to control and move the muscles needed to move the chair. This allows a large increase in mobility at standard temperatures, but is even more useful in Manitoban winters when the temperature can drop to -40 degrees Celsius. Wearing gloves is often not an option because it further inhibits range of motion. Having an affordable technology that can increase mobility, independence, and quality of life will help the 2.5% of Manitoban males that have muscular dystrophy.
The shell of the hand warmer was designed to be made out of materials that are readily available from most rehab engineering centers and fabricated using tools and techniques most rehab centers would have access to, such as heat-forming plastic and basic plastic fabrication. The parts and molds can be laser cut or cut out on a CNC machine or by hand. The inner and outer shell are heated and formed over the molds, and the remaining parts attached with a combination of brackets, fasteners, and adhesives. The gap between the inner and outer shells acts as an insulation barrier, acting on a similar principle as double-pane windows to keep heat inside the hand warmer.
To attach the design for use, the sleeve is first placed on the arm of the user. The drawstring on the sleeve accommodates different arm sizes and outer wear. Velcro located on the base of the shell is used to attach the device to the lap tray. Velcro on the sleeves attach it to the shell. This sleeve provides some cover and insulation to the opening of the hand warmer in order to maintain the internal temperature.
Here is our layout for the electrical design. We have a voltage step down on the far right, the Arduino and the breadboard in the middle, as well as the body on the top. With the help of the Arduino, we are able to set a range or bounds for the temperature that we need. So looking at this scenario, we have set the relay to turn on for any temperatures below 28 degrees and above 34. The temperature sensor will sense if the temperature is between the ranges that we set. If it's below, the relay will be turned on, sending voltage to the fan and heater. When turned off, it will turn off the fan and the heater. In this clip, we have the relay turned on, which means that the temperature is below 28 degrees, so the fan turns on to heat up to 28 degrees. Now we are pressing on the sensor so that it can gather heat. The relay will then turn off, shutting down the fan and the heater. In this clip, we actually started blowing air onto the heat sensor to cool it down. As you can see, the relay turns on, turning back the fan and the heater on again. With this method, we're able to stay in between the ranges regardless of situation.